So, I recently released a video on YouTube where I hid $100 inside the video and asked people to find it. If they find it, they keep it. Surprisingly, it took 3 days for someone to solve this challenge. That makes me wonder, is this challenge too hard? I don't know, you decide it after watching this video, because in this video, I will explain how this challenge is meant to be solved. Firstly, let me briefly explain you how I actually ended up creating this challenge. I made use of a concept called Steganography for this. It simply means hiding data in something that is in plain sight, like in an image, video, audio, etc. If you want to learn more about it, check the video that I made on Steganography. The link will be in the description or in the suggested cards above. So in this case, I wanted to hide a message in the video that will help claim the $100. I first encrypted this message using AES 256 with a 256-bit long key in hex representation. Now this is a symmetric encryption, so it means in order to decrypt the message, you can use the same key. Now I need to hide this encrypted data or this encrypted message in the video. I used an algorithm called LSB, which stands for least significant bit, to steganographically hide this message in the video. Once again, if you want to understand this algorithm, watch the video that I made. Anyway, LSB only works for images. So how do I use it on a video? Well, I simply split my video into individual frames/images, and then I chose 5 random frames from this video to encode the encrypted message. I basically split the encrypted message into parts, basically 5 parts in this case, and then I encoded each part to each of the randomly selected frames in the video. And then I created a new video with these modified frames. The video actually ended up being around 2.3 GB, which is definitely a lot for a 50-second video. The reason for the big size is because I had to use a lossless codec so that the encoded frames will not be compressed and the hidden message will stay preserved in those frames. Anyway, I also have to give the key to decrypt the hidden message, because without the key, no one can make sense of the message because it's encrypted. So I decided I should make use of audio spectrogram tricks for this. So I wrote the secret key on an image with white background, and then I used a tool called Coagula to create an audio whose spectrogram looks like this image. I then added this audio to the end of the video with some glitch video effects. And that's how I created the challenge. Oh, wait, I even tinkered with the video's thumbnail to provide some hints to you. Anyways, so here's how you were supposed to solve this challenge and find the $100 in the video. Well, initially people thought it had something to do with the base 64 string that is written on the whiteboard behind me. But did you actually think that I would keep the challenge that simple? Hell no. Anyway, if you decode that string from the whiteboard, you get the message, "Never gonna give you up." And obviously this is just a funny distraction, but many people didn't think so. Well, moving on, I provided a link in the description to download the video and the thumbnail in its original quality, because YouTube compresses the video when it is uploaded. So the first step to solving this challenge would obviously be to download the video and the thumbnail from the given link. If you look at the video's tags on YouTube, you will find something. The first 2 tags are actually hints. Stegano is a Python library to apply steganography to an image. Strings is a tool to print the ASCII readable text from a file. So if you use strings on the downloaded thumbnail image, you find these 2 interesting messages at the end. Notice what the last message is. It gives a hint that LSB algorithm is used, and it is used on the frames 156, 267, 78, 1100 and 321. Now I completely agree that it is hard to make right sense of this message when you first see it. It takes different tries to understand what it really means, but it's pretty intuitive, don't you think? LSB followed by the frame numbers. It means LSB is used on these frames. Well, I thought it's pretty intuitive. I don't know. You tell me in the comments below. So now that you have the frame numbers, you can simply take the video and then export the given frames to images. You can make use of FFmpeg or OpenCV to do that. And once you have those frames as images, you can start decoding them. Remember the other clue in the tags? Stegano. If you just Google Stegano, you will immediately find that it is a Python library for implementing steganography. You can install it and then use the lsb.reveal function on these extracted frames/images, and this will give you the messages that are encoded in these frames. Now you have to rearrange these messages according to the order of the frames that is specified in the thumbnail's hint. And once you rearrange these messages, you will get a base 64 encoded string, which, as you know, is the encrypted message. We still need the key to decrypt it. You can export the audio from the video and then open it in a tool like Audacity and have a look at the noise at the end using the spectrogram view. And you can see that there is readable text in the audio's spectrogram, which is in hex representation. And this is the key to decrypt the encrypted message. And now for the final part of the challenge, decrypt the message with the key. And to make it easier for you, I included another hint. I posted a utility script on my GitHub using which you can encrypt or decrypt a message with AES-256 using the PyCryptodo module. All you have to do is to pass the encrypted message and the key that you found in hex representation, and voila, there's your hidden message. It has a URL and a password. If you go to that URL, it will ask for your name and your email and then the password. And once you enter the password, finally, there is the Amazon gift card worth $100. You can just claim it using the code. So that is about the challenge. And congrats to the person who solved it first. I will leave a link to the write-up that the winner wrote in the description so you can check it out and read how he solved it from his perspective. I also posted the code to solve this challenge on my GitHub, so if you're interested, check the link in the description. So that will be all for this video. I hope you liked it. Thanks for watching. Thanks for participating in the challenge. I'll see you in the next video. Until then, cheers.